auto transformer is given, and three-phase induction motor stator is here. Here you can consider that DC generator with load arrangement is coupled. Rotor here is in coupling. The circuit diagram for load test on a three-phase induction motor by wait for 1 second. Please draw this diagram. So now I hope you have observed the diagram. So basically here the circuit diagram for load test on a three-phase induction motor by coupling the DC generated. Here we are implementing. Now let's see one by one that which things we need to take care in case of the temperature rise test on induction motor. Here you can see that obviously we need to test particularly the induction motor, and we are going to consider the factor of temperature rise. Means we need to deal with the temperature. Here you can consider that for continuous rating motors, the temperature rise test should be continued till its thermal equilibrium is reached. Means its final value is reached. That is ultimately no further rise in temperature rise test. Obviously a particular element, if it is reached its thermal equilibrium, after that further rise we cannot take on that particular element. Okay, so for short time rating of the motors, for short rating motors, the duration should correspond to declare the short time rating. The temperature rise is determined by following methods, basically by direct application of mechanical load, preferably load constant. Okay, whether you can use the direct application of mechanical load. Otherwise, second method is by loading of the induction motor with generator, which is mechanically coupled, and connecting the electrical load. Just we have seen the diagram. Okay, by two ways you can determine, you can just test the temperature rise test of a induction motor. Firstly, you need to direct apply the load, mechanical load, preferably the full load constant. Okay, and second one is the by loading the induction motor with a generator. Just we have coupled it with the generator, which is mechanically coupled, and connecting the electrical load. Here you can consider that in both the tests, okay, the motor is loaded up to the full load, and this loading is kept constant till the steady state temperature is obtained. And basically the temperature rise can be calculated by using the resistance method. Now we will see what is the resistance method, but I hope you have understood at So here you can consider that we have seen the temperature rise can be determined by using two ways: by direct application of mechanical load, preferably the full load constant, and second one by loading the induction motor with a generator which is mechanically coupled. Okay, in both ways you can just follow the temperature rise test. Basically we can calculate this by using the resistance method. Okay, following methods particularly are adapted for determining the temperature of windings and other parts, that is thermometer method, resistance measurement method. Okay, so let's see the thermometer method by thermometers applied and accessible for the surface of assembled motor. So this is the arrangement which is coupled with the DC generator. Okay, so we will see the practical implementation of both. Okay, so let's see what is the resistance method. In this method, the temperature rise of a winding is determined by the increase of resistance of a winding. Here we consider T1 as the initial temperature of a winding at the start, and T2 is the final steady state temperature. R1 is the initial resistance of winding at start. R2 is the resistance of a winding at the end of test. Basically, we follow this formula. R2 upon R1 is equals to 234.5 plus T2 and 234.5 plus T1. Basically, this is very important formula regarding towards the resistance and temperature relations. Please remember this is directly proportional R2 T2. R1 T1 234.5. Please remember this formula. This is very, very important. Here we need to note down the initial temperature and final temperature, initial resistance and final resistance. Okay, these type of testing we have performed in a transformer too. Initially we have measured the readings, finally we have taken the readings in a polarity, right? So, and also DC resistance test. Okay, so in this case this test is also very, very similar towards the transformer testing. Now we will see the practical implementation of particular temperature rise test on a induction motor. Okay. Only 1 minute video is there. Please focus.
On the induction motor, three-phase induction motor. This experiment is a temperature rise test on the induction motor, three-phase induction motor. Here also we are going to perform full load test on the induction motor to record its temperature rise after certain hours of operation. So temperature rise method can be once again calculated by using DC resistance method by injecting DC current into the winding after switch off the supply. At start, at ambient temperature, when the motor was in off condition, we have checked the resistance of the winding. Okay, the value is recorded 5.6 ohm. Connections are made. A DC generator is coupled. DC generator is coupled here in the induction motor. The induction motor is rated for 415 volt, 3 HP motor, 4.5 ampere current. This is the, okay, fine. So now this DC generator is coupled to the load and we have started the experiment, and after every 10-minute value, we will record, at every 10-minute value, we will record the temperature of the body temperature of the motor. The motor temperature is recorded at the frame, center of the frame, from a certain distance. After every 10-minute value, we will record the temperature. Currently, it is showing 43.4 degrees Celsius. So in this way, after every 10 minutes, we will record the temperature and we will note it down. We are waited for 1 hour. After every 10 minutes we have recorded the value. The values are recorded like this. At 10 minutes body temperature was 49.5, 20 degrees Celsius. It is 55 once again. Then 20-minute value 55, 60-minute value also, 40-minute also 54.5, 50-minute value 55, and 60-minute value also 55. It means that steady temperature is achieved. At this time now, we will switch off the supply, inject the DC current into the winding, and we will record the hot winding. After switch off supply, we will inject DC current. We will disconnect the motor from the AC input, and we will inject DC current into the motor, and then we will record the voltage and current drawn by the winding for after every 2 minutes after switching off the supply. So 2 minutes, 4 minutes, 6 minute value we will record voltage and current, and then we will plot the graph in between time versus resistance, and that graph to intersect the y-axis. So resistance at the time of switching, that will be your hot resistance. Okay, and using the initial value resistance and the final value resistance, we will calculate the temperature rise by convention method. Thank you. DC resistance setup is connected. Motor is disconnected from the supply. Okay, AC input supply. DC source is now injecting into the motor in between two terminals of the delta winding. And we will record the this experiment is a temperature rise test on the induction motor, 3-phase induction motor. Here also we are going to perform full load test on the induction motor to record its temperature rise after certain hours of operation. So temperature rise method can be once again calculated by using DC resistance method by injecting DC current into the winding after switch off the supply. At start, at ambient temperature, when the motor was in off condition, we have checked the resistance of the winding. Okay, the value is recorded 5.6 ohm. Connections are made. A DC generator is coupled. DC generator is coupled here in the induction motor. The induction motor is rated for 415 volt 3 HP motor, 4.5 ampere current. This is the okay, fine. We'll talk. So now this generator is coupled to the load, and we have started the experiment. And after every 10-minute value, we will record. At every 10-minute value, we will record the temperature of the body temperature of the motor. The motor temperature is recorded at the frame, center of the frame, from a certain distance. After every 10-minute value, we will record the temperature. Currently, it is showing 43.4 degrees Celsius. So, in this way, after every 10 minutes, we will record the temperature and we will note it down. We are waited for 1 hour. After every 10 minutes we have recorded the value. The values are recorded like this. At 10 minutes body temperature was 49.5, 20 degrees Celsius. It is 55 once again. Then 20-minute value 55, 60-minute value also, 40-minute also 54.5, 50-minute value 55, and 60-minute value also 55. It means that steady temperature is achieved. At this time now, we will switch off the supply, inject the DC current into the winding, and we will record the hot winding. After switch off supply, we will inject DC current, we will disconnect the motor from the AC input, and we will inject DC current into the motor, and then we will record the voltage and current drawn by the winding for after every 2 minutes After switching of the supply, to 2 minute, 4 minute, 6 minute value, we will record voltage and current, and then we will plot the graph in between time versus resistance, and that graph to intersect the y-axis, resistance at the time of switching. That will be your hot resistance, okay, and using the initial value resistance and the final value resistance, we will calculate the temperature rise by convention method. Thank you. DC resistance setup is connected, motor is disconnected from the supply, okay, AC input supply. DC source is now injecting into the motor in between two terminals of the delta winding, and we will record the voltage and current after every 2 minutes. उसका reading. Voltage is 12.7 and current is 0.472. 0.47. 0.47.
Hello, welcome to the postgraduate program in Artificial Intelligence and Machine Learning offered by the University of
स्टार्टिंग ऑफ 3 फेज इंडक्शन मोटर में हमने पहले 2 वीडियोस पहले देख चुके हैं जो कि 2 स्टार्टर पर बेस्ड हैं, DOL स्टार्टर एंड स्टार डेल्टा।
So I hope you have understood the temperature rise test. In a temperature rise testing, what we have seen the arrangement. Okay, we have measured the temperatures, right, up till the steady state value is obtained. Okay, so then by using this formula, we can calculate the resistance. Okay, the temperature rise may be obtained by the ratio of resistance R2 by R1 is equals to 34.5 plus T2 to 34.5 plus T1. And this way we need to calculate it. Okay, so I hope you have understood this methods in detail. We will recall again this temperature rise and method of loss separation test and the next lecture. Okay, if any doubts, still we have 2 minutes, you can ask me. Okay, basically I have told you this point is also very, very important for large motors. We need to have the arrangement of a dynamometer, rope and pulley and beam clamped. Okay, so please focus here, and I hope you have understood the precautions and also up to what value we need to take care of the induction motor. Okay, so any doubts? Please observe this diagram. Tomorrow we are going to continue the synchronous motor testing. Please observe this.